here we're going to look at topic 72, example 3, where we solve quadratic equations by factoring. And what we're going to use is something called the zero product property. So the zero product property states that if a product of real number factors is 0, then at least one of the factors must be 0. In the case of two factors, if a times b equals 0, then either a equals 0 or b equals 0 or both. And then to use the zero product property, which we'll use in these examples, you rewrite the equation so there's an expression equal to 0, then factor and solve. So effectively what they're saying, or what the zero product property is saying, is if you multiply two numbers, whatever they happen to be, or two variables in this case, like a times b, and we get 0, the only way for that to be true is if either a is 0, b is 0, or both a and b are 0. So what we're able to do is we can take each individual piece and we could take this, split it up and say that a is equal to 0, b is equal to 0. And that's our zero product property. Okay, so let's go through this. And to use the zero product property, remember to rewrite the equation so there's an expression equal to 0. Meaning in part A, I can't have this equal to 42. All right, I need to bring this 42 to the other side. So now I have x squared plus x minus 42 is equal to 0. And now I can use the zero product property. So once we've rewritten that equation, you would then factor and solve. So we have a 1 here. Doing what we've done in the previous two videos, we want factors of negative 42 that have a sum of a positive 1. So factors of negative 42 have a sum of 1. All right, 42 is going to have a lot of factors. And again, as you get better at this, you'll start learning how to not really worry about certain numbers. But I'm going to list all of them just for the sake of doing so. And then again, as you get better, you'll save yourself some time. So we would have 1 and negative 42. Negative 1 and positive 42, 2 and negative 21, negative 2, positive 21, 3 and negative 14, negative 3 and positive 14, 4 does not work, 5 does not work, 6, so we have 6, negative 7, or negative 6, positive 7. And then 7 we already used, 8 wouldn't work, 9 wouldn't work, and so on. All right, so it wasn't too bad. We have, I believe, 8 set of factors here. So we would try and find the sum, and we're looking for a sum of 1. These top ones clearly are not going to work, but again, I'm just going to write out the numbers anyway so that you can see the whole process. So 6 and negative 7 give us a negative 1, which is the right number, wrong sign. So that's a good chance that negative 6, 7 is what's going to work, which it does. So these would be my factors. So I would factor this, and I would rewrite my expression as x minus 6 times x plus 7. And I would keep that equal to 0. So remember, these two numbers are the factors that we used. And now from here, we rewrote the equation so the expression is equal to 0. We then factored it. And now we can solve it by using the zero product property. And we can take each one of these pieces, each one of these factors, x minus 6, set it equal to 0, and x plus 7, and set that equal to 0. So I then solve each individual one. I get x equals 6, subtract 7, I would get x equals negative 7, and these are my solutions. Okay, those are the zeros. If this was graphed, we're not going to graph this, but what would happen, remember that the zeros, so we have 6 and negative 7 here. Whatever my graph looked like, I don't know the exact curve, but what would happen is it would go through negative 7 and 6. Okay, I don't know how stretched it is or how compressed it is, but that's what your graph would look like. It would go through those zeros. Okay, don't worry about the graph. We don't have to do that right now, so I don't want to confuse anybody. But that's your process. You set everything equal to 0. You factor the expression. Once you have your factors, you then use the zero product property and set each piece equal to 0. All right, in part B, we definitely don't have this equal to 0. So what I'm going to do is I want to move the 9x over. I'll do this one step at a time. So get 2x squared plus 9x equals 5. And then I would subtract 5. So I get 2x squared plus 9x minus 5 is equal to 0. Okay, here we're going to need to use the factor sum method. However, we need to use the AC version. So if you remember, going back to example 1, this AC method where we had to multiply A times C, because the A value is something other than 1. So I need factors of 2 times negative 5, right? A times C. So that's going to be negative 10. And I would need a sum of a positive 9. Always be careful with your signs. So double and triple check them. And there's 2 negative 5, so we want factors of that negative 10, which comes from multiplying 2 times negative 5. Okay. So factors of negative 10, we have 1 and negative 10, negative 1 positive 10, 2 negative 5, negative 2 positive 5. Once again, as you get better at this, you can start kind of taking some shortcuts here. So 1 and negative 10 would be negative 9. That doesn't work. Negative 110, that's a positive 9. That does work. So we're going to use negative 110 as our factors. So from here, or from that step where we left off, we would have 2x squared. The minus 5 and the 2x squared come down. And then what we want to do is we want to take that 9x and split it into 2 terms. So I'm going to split them into negative 1x and positive 10x. You have the choice of the order you put them in. The order won't matter. Sometimes it makes the problem easier. Sometimes it makes the problem more difficult. But the order is not important. If I put the 10x first, as long as I follow the right processes and steps, I will still get the correct answer. So from here, we're then going to factor by grouping. So I'm going to take my first 2 terms, the 2x squared minus 1x, take out what they have in common. In this case, that would be x. I'd be left with 2x minus 1. I'm then going to do the same thing with my third and fourth term, the 10x minus 5. So they would have a 5 in common. I would factor out a positive 5. I'm left with 2x minus 1. Remember, when you get to that step, these two expressions should be identical. If they are not, something is incorrect. So you have to go back and figure out what went wrong. Take those two expressions that are matching, write them as 1, as if you factored it out. Take your 2 leftover pieces, remember this x and this 5 to go together, and that would still be equal to 0. Now we've factored everything out using our AC method. You then can use the zero product property, which tells us that we can take each set of factors, or each factor, 2x minus 1, and set that equal to 0, and x plus 5 and set that equal to 0. I'll do the second one first because it's quicker. So x is equal to negative 5 would be one solution. And then over here we would solve for x by adding 1 and then dividing by 2. So x would be equal to 1/2. Right, and those would be the solutions. Again, if you wanted to graph this, what would happen, remember these represent your zeros. So I would have a 0 at negative 5 and at positive 1/2. And my parabola would look something like this. Again, not the best of parabolas, but it looks something like this. I don't know how stretched or compressed it is, but I don't know how far it dips. I don't really know where the vertex is. I'm not going to figure that out. But that's where your zeros are. That's where it would cross the x-axis. Right, but let's get rid of that. And we're only concerned with solving and finding the zero product property right now. It'll take some getting used to. It does take some practice. These are at times very involved problems that take a lot of steps. They're kind of easy to make mistakes on, especially as you're doing the factor sum chart. So just be careful, learn the process, practice it, be willing to challenge yourself with it, and eventually you will get the hang of it.